Hello everyone, in this video we'll see binary trees search for a node. We have given one binary tree and one node, so we have to find whether this node is existing in this tree or not. The node stands for the data what the node contains. For example, I'm searching for 11. This tree, yeah, 11 is there, so we have to print true or false or 1 or 0 with this. So I have a node definition here. So node contains of data and left and right pointer. And here's my code snippet. My approach how I'm going to solve this problem is, here you have the search function and it expects two parameters like node and expected data. The first line is if the node is null, I have to return false. If no data or node is attached with these kind of nodes, so I have to return it as false. This is a primary condition we have to include. Then if the node contains this data of what we present in this node is, then if it is equal to expected, then you have to return it as true. And then if it is not matching, you have to travel at the left subtree or right subtree, and you have to check the OR condition of the both left and right. So if any left side or right side, any direction, if it exists, it returns that as true or false in this statement. So we'll see in this tree. Here I'm looking for the node 30, so node exists here, so we have to print found R1. In this one you can see there is, I'm looking for node 100. This is not existing, so how to print not found. And in this tree we are checking for node 60, it's there, so no, this node found, so how to print found. So how it works is, initially I'll pass this node 10. For example, here in this example we'll take this 50. I'll pass this node 10, so it triggers the nodes is null or not. So it is not null, so it will not go to this line, and it will go to the next line. It checks for this node is expected one, and no, it's not, so it will not go this return also, so it will go to this last line, and the left subtree argument triggers, so it will comes to here, and then here also these conditions will not be satisfied, so it continues to trigger this left side, and here also it is not matching, and here no nodes are there, so these lines will trigger at this point. When it's having the node as null, then it will return false, so it will return false, and here this node also will return false. But when it comes to the right side, this line node expected is there, so it will returns true. So we have to OR these two conditions. So if you are returning it as 1 and 0 with ORed condition, any of the input or any one of the input, if at least is up, then the answer is also up. So that's the OR condition. So what if this 20 returns is, yes, it exists, like true. And here also these calls also will be triggered. When it goes here, there is no data is existing in this part. It goes here and then here and then here, but all those will return as no, it not exist, no, it not exist. And ultimately what 10 decides is, here I exist, here it does not exist, so I'm ORing these two conditions. So the answer is somewhere it is there. So we don't need a path where from where how it goes and all, we just need whether it is exist or not. Okay, we just try this example. Here I have 10 and I'm looking for the node with data 100. Here you can see it goes here. First it check at the root, it's not there, so it triggers at the left side, and it goes 40 here it is not there, so it will go deep inside. 40 here also not there, so it will return not exist, and here this 20 also not exist, and here it is not exist, so here also not exist, here also not exist. So ultimately when this 10 or these two not exist, the answer also not exist, so it is not found. So we quickly jump back to the Visual Studio Code and we'll see how to implement this search functionality in the binary tree. So I have basic setup here. I included the necessary import statement, and I have node class and its definition. Here we have some properties, public properties, and here I have constructor. In the main function I have three trees, namely these three trees. This first one, the second one, this tree, and this third tree also in a coded format. So I'll write the search functionality as int search. I have to pass two arguments, namely node root and int expected. If the node root is null, I have to return 0, which means it's not there, or else if the node root data equal to my expected data, then return 1, or else I'll travel return searching the left side. So root left, how to pass the expected one, and or search root right direction with the expected one. Here I have to call this. So what I do is cout n pointer search. I have to pass this n, and in first tree I'll send 50, so 50 is there, so it should print 1. I'll copy this cout for others also, m and y and y. Here I'm looking for the same 50, but it does not exist in this tree, so it should print 0, and in this one it does exist, so it should print 1. So format this document and run it. So 101 is the answer. I'm checking for 50, it does exist in this one, so it is 1, and in this tree 50 is not there, so 0, and the next tree also 50 is there, so it should print 1. So this is how the search functionality in a binary tree with the data which we are looking for is working. So hope you understood the problem and solution, and thank you for watching this video.